So just as a few weeks ago, when you were first learning about electric fields, we wanted to visualize them so that you could start to get an intuition for them. We're going to do the same today with magnetic fields. So what I have here is an ordinary bar magnet. Stick to your refrigerator. Sticks to that. And you put that there. And the way I'm going to visualize the magnetic field around it is I'm going to sprinkle it with iron filings. And each little iron filing behaves like a tiny, tiny, tiny compass needle, and it will line up in the magnetic field. So let's see what we get when we sprinkle this with magnetic filings, with iron filings. And do a little tap, and voila. There is the magnetic field pattern from a dipole magnet. You can see the magnetic field lines coming out of one pole, going around like this into the other pole, coming out of this pole, going around like this into the other pole. I don't actually know which one is north and which one is south. It might be that this is north, the field lines are going around that way, or it might be that this is north, the field lines are going around that way. The iron filings don't tell me the direction of the field line, but they show me the orientation of the field line, and I can see this classic dipole pattern, in this case a magnetic dipole. So now what I'm going to do is I'm going to clear this, and I am going to try and do something that would be easy to do with an electric dipole. With an electric dipole, if I had an electric charge plus and an electric charge minus, I could separate them. So I'm going to try and do the same thing. I've got a magnetic north pole and a magnetic south pole. Let me try and separate them and see whether I get two isolated Coulomb magnetic charges. So I'm going to break this magnet, and here it is, broken into two pieces. And I've separated it, and now let's see whether I get two isolated monopoles the way you would if that had been an electric dipole. If that had been an electric dipole, I would have a plus on one side and a minus on the other side, and I'd have two isolated or separated Coulomb fields. Let's see what I get instead. And what you see is that instead of getting two isolated Coulomb fields, I get two dipoles. So I broke the magnet into two pieces, and instead of getting an isolated N over here and an isolated S over there, I have a north-south dipole here and then a north-south dipole here. So when I break a dipole magnet into two pieces, I get two new dipoles, and this is one of the central differences between magnetism and electricity.